In this video, I'm going to go over the two forms of a quadratic function, factored and standard form. So I'm going to split the page in half. Standard form. And factored form. There's a third form, it's called vertex form, but we're not going to go over that one today. We will save that one for another time. The standard form of a quadratic function is y equals ax squared plus bx plus c, where a is not equal to 0. The reason a can't be equal to 0 is if you have a 0 right here, that essentially gets rid of the x squared value and makes it a linear function. So a is never allowed to be 0. In standard form, we do have one feature of our graph that's revealed. So I'll put that in a different color. Okay, so the feature revealed in standard form is our y-intercept. And it's actually our c value. So this value right here, c, is the y-intercept of our quadratic function. So if you're ever given an equation in standard form, you already know where it's going to be intersecting the y-axis. Factored form is a little bit different. So factored form is y equals a times the quantity of x minus r sub 1 times the quantity of x minus r sub 2. Now we have these two r values here with two different numbers underneath of them. And again, this is where a is not equal to 0. If your a is equal to 0, it's going to cancel out this first set of parentheses, and then pretty much there's nothing left there for us. So the feature revealed in this one is another type of intercept, but one we don't usually talk about when we're using linear or exponential functions. So the feature revealed are our x-intercepts. So I did put in here an s in parentheses because there's three different types of x-intercepts that we can be looking at in terms of a quadratic function. So we call these x-intercepts three different things. An x-intercept can be called a root, a 0, or a solution. And we'll be using all three of those throughout this week so that we don't ever forget that those are the three names. Now, these are represented by R1 and R2 values. And we'll go through how to actually find those because there is a process that we use. So I'm going to close this off. Now, I told you guys earlier that there are three different types of solutions. Okay, we wrote this word up here. So I'm going to write three different graphs, and they're not going to be drawn to scale as much as I would like for them to be, but that's just because I'm not an artist, and I hear teachers say that all the time, but I truly am not an artist, so my apologies. So when we are talking about solutions, we're talking about our x-intercepts, or in other words, where it intercepts our x-axis. And I'm actually going to highlight that so we can focus on how many times it's actually intersecting. So if we look at this one, it is only intersecting one time. And an example of an equation that would result in that, so let's say that this is our standard form. And if we go back and we think about how we would factor this, there's only one set of factors for 1. It's 1 and 1, and 1 plus 1 is 2, so we could rewrite this as y equals x plus 1 squared. In this case, we have one root, and our y-intercept is 1. Okay, so what you would be able to gather from this is we have one solution. Okay, or in other words, one root. Okay, moving on to the second one. This is the one that we probably work with most in class. So let's say that we have an equation, and again, it's not drawn to scale, but the equation for this line would be y equals x squared minus 2x minus 3, and that can be factored to give us the equation y equals x minus 3 times the quantity of x plus 1. Here we have two solutions. There's 2 points at which it intersects my x-axis, so there are 2 solutions. Or in other words, 2 roots. This last one is different from both of these. If we look closely, it's not intersecting at all. And so in this case, we do have an equation in standard form. We could say that this is y equals x squared plus 2x plus 3. And if I try and factor this, there are no factors of 3 that will give me a solution, or sorry, a sum of 2. So there is no factored form here. And along with that, there are no solutions. Or in other words, no roots. The last part of this, which I am going to have to actually turn the page, is finding the roots. So we're going to actually use both of these equations to do that, and I'll use a couple other ones. So I'm going to flip the page. So now we're going to look at finding the roots, because you won't always be given a graph. Sometimes you may only be given an equation. So let's say that we're given the equation y equals x minus 3 times the quantity of x plus 1. Now, if we're looking for our x-intercepts, if we think about what it means to be an x-intercept, that means that it's crossing the x-axis. In other words, my y value, because we're not going up or down at all, is equal to 0, because this line right here would be y equals 0. So we're going to take both of my equations and we're going to set them as y equals x minus 3 and y equals x plus 1. And I want to know what is the value when y is 0. So I'm going to replace y with 0. Whoops, it's supposed to be 0. And my job is to solve backwards for x. In this case, I would need to add 3 to both sides. So my x value is 3. On this one, I would subtract 1. So my x value is -1. So the roots of this equation, okay, I would be able to say roots, zeros, or just x equals 3 and -1, and that would be the solution to this equation. Now, you won't always be given one that's quite as easy as that. You might be given one that actually has a number in front of my x value. So let's say that we're given y equals 2x plus 1 times the quantity of 3x minus 4. In this case, I'm going to do the same thing. I'm going to set them both separately equal to y. I didn't mean to put parentheses on that one. That's my bad. And I'm going to set them both equal to 0. So I'm going to change y to be 0 because I want to know what is the value of x when y is 0. And I'm going to solve backwards for this x value. My first step would be to subtract 1 on both sides. So I have -1 is equal to 2x, and then I would divide by 2, and I would be left with negative 1/2 is equal to x for this one. And over here, I would need to add 4 to both sides. Divide by 3 on both sides. And I would be left with 4/3 is equal to x. So the two roots, or solutions, to this quadratic equation would be negative 1/2 and 4/3. Now, it's not the only way to write my answer. If we know that they are x-intercepts, we can also write them as points. Our x value is negative 1/2, and my y value is 0, because that's what I set my equation up to. And the other one would be 4/3, comma, 0. So you'll see it written both ways. I prefer to write it this way, but this is also correct.